Hello students, today we are going to see some important explanations of the following reaction in that one among acylation. Acylation is nothing. Active hydrogen atom of an amine can be replaced by acyl group. What is the product you will get it? You will get N substituted amide. What is the catalyst we are using? We are using strong base of pyridine we are using. Come on, let us go for that reaction. Or NH2. I just mentioned because active hydrogen can be replaced by what it is? Acyl group of carbon. Okay, so this is acyl group. Okay, RC double bond OCl acid chloride also we can say. Acyl group also we can say. Now, in the presence of pyridine, okay, now why do we use pyridine? Pyridine actually it is a stronger base than amine. Now, actually acylation, the word comes from Friedel-Crafts reaction. What is the Friedel-Crafts reaction? What are the reactant can be here? So here actually acid chloride or acetic anhydride in the presence of aluminum chloride will be there. But here, acid chloride is there. In the presence of pyridine is there. Why you know? Pyridine, it is a stronger base than amine. Suppose you are using aluminum chloride. Aluminum chloride, it is actually Lewis acid. This combined with the base. This is actually base. Acts as a base now. So both combine to form salt formation. To avoid that only, we are using pyridine. Pyridine, it is a stronger base than amine. So that we are using and we are getting what it is, amide compound. Now what is the product you will get it? Okay, now this one it is can be removed by this and R NH C double bond O R plus HCl. So what do we call this is N substituted amide. Okay, now acidic anhydride also we can go. Or NH2. I just mentioned like this only. Acetic anhydride CH3CO, CH3CO both combined together. Also, this is called acetic anhydride. The same way, pyridine. Pyridine. Here, what it is? Acetic anhydride. Okay, so what is the product you will get it? Here also you will get the same product only. Now here what it is? R NH C double bond O R plus CH3 COOH acetic acid. So here N substituted amide only you will get it. Hope you're clear. Now this is CH3COOH acetic acid you are getting, then another CH3CO. This combined with that, you will get what it is, N substituted amide. Okay, here CH3 group is there. No, so the N-methyl amide. So here CH3. So N-methyl. The substituted compound, it is nothing, methyl group. So N-methyl amide formation you will get it. Okay, now let us go for the particular reaction. I just put it here. CH3 methyl amine combined with the methyl acetyl chloride CH3 CH3COCl CH3COCl. How do we get it? CH3COOH. This OH can be replaced by Cl. So that is what CH3 COCl. So, okay, that is the way acetyl chloride, acid chloride. That is what we are telling. It's a acid chloride also. Okay, hope you're clear now. Now the same way here instead of R, same thing only CH3, and here also instead of R, you will get CH3. Easy. You remember the tricks. So N substituted amide. N substituted amide. It is nothing. What it is? N-methyl acetamide. What do we call? N-methyl acetamide. Acetamide. Hope you're clear with this. And then pyridine, you are heating this reaction. Okay, hope you're clear. Okay, now next one here. This also. Methylamine, CH3, NH2. The same fine. Instead of here R, here CH3. Okay, so here also N-methyl acetamide. Okay, I hope you're clear with this reaction. What is acylation? What is the product you are receiving? Why do we use pyridine? Now, one more question. Aniline do not undergo Friedel-Crafts reaction. Why? Suppose if they are asking such kind of question, what is the answer? Actually, for Friedel-Crafts question, already I mentioned Friedel-Crafts reaction is what it is. What is the catalyst we are using? We are using aluminum chloride. So aluminum chloride, it is an acidic medium, Lewis acid, and this is a base. So you will get that salt formation. So to avoid that only, we are using pyridine. Okay, now here aniline we are using. Okay, now aniline do not undergo what it is Friedel-Crafts reaction, but it will give that amide group. When it will give the amide group in the presence of pyridine. Okay, now here what it is C6H5. It's simple. Instead of CH3, you just remove that what it is alkyl and you just add that aryl C6H5NH2. The same acidic acid chloride, acidic anhydride, both are same only. So in the presence of pyridine, so what is the product you will get it? C6H5. C6H5 NH C double bond O CH3. So what is the name of it? N-phenyl acetamide. N-phenyl. N-phenyl acetamide. Okay, hope you're clear. CH3CO. NH C6H5. So N-phenyl acetamide. The same way here also. Instead of C6 CH3 C6H5 we are using. Okay, now here also the same N-phenyl acetamide C6H5 NHCO CH3. So N-phenyl acetamide. This is acetamide CH3CONH. It is acetamide. Okay, now this is combined with the phenyl group. So it is what it is here N-phenyl acetamide. Hope you're clear. Okay, now the next question, how do we get N-dimethyl acetamide? This is very simple. Okay, primary amine combined with acetyl chloride in the presence of pyridine, you are getting N-methyl acetamide. Now what is the question? How do we get N-dimethyl acetamide? Let us go for the secondary amine. Secondary amine, what it is? CH3NH here CH3. So this is secondary amine, right? So secondary amine combined with acetyl chloride. I just put it like this. C double bond O Cl. CH3CO CH3COCl. Okay, I just put it ulta. In the presence of, by the time I think you people will know, pyridine. Why do we use pyridine also? You know very well. Okay, now what happened? This hydrogen combined with this Cl, you will get HCl. So then what you will get it? CH3, N, and here CH3, and here what it is? C double bond O, CH3. So N, dimethyl acetamide. Okay, now this hydrogen has removed by Cl, so you will get what it is? It's Cl. Okay, hope you're clear. So what is the name of it? Here, this is the answer. N dimethyl acetamide. Hope you're clear with this. Suppose if they are asking such kind of question, I think you are able to answer very clearly. Instead of what it is CH3, if they are giving C2H5, just to replace C2H5. That's all. Hope you're clear with this. Okay, now let us go for the mechanism, how it reacts with that mechanism. It's very, very important. Okay, let us go for the mechanism. Now let us go for that mechanism. Here CH3 NH2. Okay, here this acts as a amine, acts as a nucleophile that is combined with acetyl chloride CH3 C double bond O Cl. Now this nucleophile which is going to attack that carbonyl carbon. Now what happened? This goes over here. So in the presence of pyridine. Okay, now what happened here? You will get it. So here CH3 N, here hydrogen and here also hydrogen. You will get the positive charge over here and you will get the negative charge over here. And here Cl and here CH3. Now what happened? This positive charge comes over here. This hydrogen which is coming over here and this one which is again now completely this is going away and you will get what it is HCl formation. Okay, now here CH3 NH C double bond O CH3 and HCl. You will get that complete HCl formation and CH3 NHCO CH3. This is what it is. N-methyl amide, acetamide. N substituted amide I mentioned, So N-methyl acetamide. Acetamide. So this is N-methyl acetamide. Okay. Suppose here in the C6H5 it has mentioned N-phenyl acetamide. Anilide also we can say. Okay. Aniline suppose reacts with acetyl chloride in the presence of pyridine. You are getting N-phenyl acetamide or anilide. Another name of that N-phenyl acetamide is also known as anilide. Hope you're clear with this idea. Okay, let us go for that. Another one more explanation of the reaction. The next question, benzoylation. Okay, what is it benzoylation? Benzoyl chloride reacts with amine in the presence of pyridine. You are getting that N substituted amide compound. So that is called benzoylation. Okay, now CH3 NH2 active hydrogen combined with C6H5 C double bond O Cl. Okay, this is benzoyl chloride. So then this is actually acid chloride only. C6H5 COOH. This is benzoic acid. This can be that OH can be replaced by Cl. So this is benzoyl chloride. That's what acid chloride I just mentioned. In the presence of pyridine. So, what is the product you are getting? This HCl can be removed. So, what happened here? What happened here? This is CH3 NH C double bond O C6H5. Okay, now what is the name of it? This we can say N-methyl benzamide. Benzamide. Okay. Now you can ask the question. Now aniline reacts with acetyl chloride. What is the product? What is the difference between these products? Come on, let us go for it. C6H5 NH2 combined with here what it is? CH3 C double bond O Cl. So in the presence of pyridine. Okay, now what happened here? Hydrogen, no? This active hydrogen combined with that chlorine, you will get what it is? HCl. Here also HCl will be removed. So here what happened? C6H5 NH C6H5NH C double bond O CH3. So what is the name of this product? What is the name of this product? What is the difference between these different products? CH3 NHC double bond O C6H5. So this is called what it is? N-methyl benzamide. Whereas here, what is the name? N-phenyl. N-phenyl acetamide. Acetamide. See the difference between acetamide. See the difference between this and this. Now, where there is a CO group attached, CO group which is attached with that CH3CONH. So, this is called acetamide. Whereas here, C6H5 C double bond ONH. So, this is benzamide. Whereas here, this is acetamide. So, phenyl group, aniline reacts with acetyl chloride, you are getting N-phenylacetamide, whereas what it is, methylamine reacts with benzoyl chloride, you will get N-methyl benzamide. Both are looking somewhat little bit similar, but it is not same. It will be different. That is what purposely I brought this questions here. Suppose if they are asking, you are not supposed to confuse. Now you see in that first reactant, where is that? Whether it is a methylamine or aniline, that you have to identify. Hope you're clear with this. Okay, the next question, carbyl amine test or carbyl amine reaction. Okay, in this, what are the ingredients are required? Methyl amine CH3 NH2 combined with chloroform CHCl3 plus KOH, alcoholic KOH, alcoholic KOH. So what happened? Here you will get CH3NC. Okay, CH3NC, what do we call? It is methyl isocyanide. What do we call? Methyl isocyanide. And you will get what it is, KCl plus H2O. Now KCl, the Cl3 no, so that means 3 KCl and 3 H2O. 3H2O. Okay, so this is what it is, methyl isocyanide. Okay, now this is methyl amine, so you are getting methyl isocyanide. Suppose aniline C6H5NH2 combined with the same chloroform CHCl3 plus KOH, the same thing only, alcoholic KOH, alcoholic KOH. Okay, so what you will get it, C6H5NC. So phenyl isocyanide. What do we get? Phenyl isocyanide plus KCl plus H2O. So here 3, here also 3 when we put it here. Why, you know, to replace this Cl3. Okay, now this is, what is the name of this? Phenyl isocyanide. Okay, hope you're clear with this phenyl isocyanide, methyl isocyanide. Okay, in this one important point, this is intolerable smell. You cannot bear that smell when you are going for this carbyl amine test in that practical classroom. Okay, you cannot bear that smell. That much bad smell you will get while preparing that methyl isocyanide. How do we prepare that methyl isocyanide? Methyl amine combined with chloroform in that alcoholic KOH, you will get what it is, methyl isocyanate. The same way aniline, what it is, C6H5NH2. One thing, this reaction can be done only in the primary amines only it is possible. It cannot go for the secondary amine. Okay, now this, as you are mentioning about that chloroform and alcoholic KOH, one more reaction also you just correlate with that. Chloroform with that KOH, where you will get it, phenol reacts with chloroform and alcoholic KOH. What you will get it, salicylaldehyde, Remer-Tymans reaction. Hope you remember. So whenever you are learning, you just correlate with it, so you will not forget this points. Okay, hope you're clear with it. What is carbyl amines reaction and what are the products you are getting, and what is carbyl amine test also you know very well. Hope you're clear with this. Okay, let us go for the next question. Now we are going to see another one more question. Reaction with aryl sulfonyl chloride. What is aryl sulfonyl chloride? Benzene sulfonyl chloride only we are bringing here. Okay, benzene sulfonyl chloride C6H5SO2Cl. This is benzene sulfonyl chloride. Okay, now let us go for that benzene sulfonyl chloride. This is benzene ring connected with S double bond O here, double bond O here, Cl. Benzene sulfonyl chloride combined with the CH3. Here NH2 primary amine. Okay, so active hydrogen is here. Okay, now what happened? These both connected when you warm up. Warm. Okay, so warm up, what will happen? N-methyl benzene sulfonamide formation, you will get it. What it is? N-methyl benzene sulfonamide. Here this is benzene ring. Yes, double bond O. Here double bond O. Here what it is? NH. Here CH3. So here what you will get it? N-methyl benzene sulfonamide. Sulfonamide. Okay, N-methyl benzene sulfonamide. Now, this hydrogen, it is acidic hydrogen. This hydrogen, which is connected with that nitrogen, no, that is attached with the sulfonyl group, which is electron withdrawing group. So, what happened? This compound reacts with sodium hydroxide. That will be soluble in that, and you will get the homogeneous solution. That homogeneous solution undergoes for that acidification, you will get what it is? Precipitate, that is sulfonamide. Okay, so benzene sulfonamide we can identify. Okay, now suppose we are going for that, this is primary amine. Now sir, shall we go for that secondary amine? This is primary amine and this is a secondary amine. So secondary amine, what is happening? Let us go for it. The same here. Yes, a double bond O, here also double bond O, here Cl combined with what it is? NH, here CH3 and here CH3. Okay, this is what secondary amine. Now, here these combined together, the same warm up method, only warm. Okay, so what you will get it? N dimethyl benzene sulfonamide, you will get it. The same structure, only thing, one methyl group extra. Okay, so here what it is? Yes, double bond O, and here double bond O, and here what it is? N CH3, and here CH3. So what you will get it? N dimethyl benzene sulfonamide. Benzene sulfonamide. Okay, N dimethyl benzene sulfonamide you are getting. Okay, now there is no hydrogen which is free from that acidic hydrogen, that is connected with what it is? Sulfonyl group. Sulfonyl group, what it is? Electron withdrawing group. So naturally it will be reacted with sodium hydroxide, it will be dissolvable. Okay, that undergoes with that acidification, you will get that precipitate formation. Whereas tertiary amine do not undergo for this, what it is? Sulfonyl chloride do not react with tertiary amine. Okay, now why it does not? Because there is no hydrogen over here. Okay, for tertiary amine, active hydrogen it is missing, so it do not react with the sulfonyl chloride, benzene sulfonyl chloride. Okay, now suppose if you are using para-toluene sulfonyl chloride, what will happen? Para-toluene sulfonyl chloride, what will happen? So what it is para-toluene sulfonyl chloride? Okay, CH3, here benzene, here benzene ring connected with, yes, double bond O, here double bond O, here Cl. So this is para-toluene sulfonyl chloride. Okay, the same reaction only takes place. So that here Cl, which is connected with the primary amine, so you will get that same thing only, but only thing what it is? Para-toluene sulfonyl chloride you will get instead of what it is? Benzene. So instead of benzene, you will get the para-toluene sulfonamide. Here N dimethyl para-toluene sulfonamide, like that you will get it. Tertiary amine, it do not react. Why? It does not have active hydrogen. Hope you're clear with it. Is it visible? Hope Hope you're clear with this. Here one important word I missed, that is Hainsberg reagent. Hainsberg. Hainsberg reagent. Okay, what it is Hainsberg reagent? This is benzene sulfonyl chloride is also known as Hainsberg reagent. Okay, for primary amine, when it reacts with sodium hydroxide, for this compound, when it reacts with the sodium hydroxide, you will get that homogeneous solution. Whereas here, in this, there is no hydrogen in it. So this one, when it combined with sodium hydroxide, you will get insoluble precipitate, you will get it. Tertiary amine do not react with that. Okay, so hope you're clear with this idea. Hainsberg reagent is nothing what it is. Benzene sulfonyl chloride. Okay, now we are going to see electrophilic substitution reaction. Here, electrophilic substitution reaction. Aniline. Aniline is having lone pair of electrons. So the lone pair of electrons, instead of donating at that lone pair of electrons involving for that resonance fact. Okay, so what happened? Electron density increases on the benzene ring. So naturally, it attracts more electrophiles towards that reaction. So instead of benzene ring, aniline is more reactive, so it attracts that electrophilic substitution reaction. Electrophiles it is attracting, so naturally benzene, more than that, aniline is more reactive. That is what directing group or activating group we can mention. Hope you're clear with it. Okay, now what are the activating group, directing group? Let us go for it. The next question, why aniline gives ortho and para substitution product? For that, we have to go for the resonance point only, the lone pair of electrons which is involved for the resonance. So what happened? You will get that negative charge of that aniline will go for it. Here what it is? Here one, yeah, I just put it here. Here one and here one and here one. So you will get a negative charge on ortho and para position only, not in the meta position. Meta position there is no negative charge. Only ortho and para position only the negative charge sits. So electrophiles will go and attach with ortho and para position only instead of meta position. Now for example, here aniline reacts with bromine water. This is aniline reacts with bromine water. If you heat, what happened? You will get 2,4,6 tribromo aniline. You will get it. Here NH2, here Br, here Br, and here Br. So you will get 2, 4, and 6 tribromo aniline. Tribromoaniline, you will get it. So this is that example for you. Why this 2,4,6 tribromoaniline? This place has taken due to the resonance of that aniline. Okay, now one more point where it can be reduced. Now I'm going to give that idea for that point. Okay, hope you're clear with this electrophilic substitution. Why we are saying it is an activating group or directing group, and where it has directed, it is ortho and para position. Why it has taken for that ortho and para position? Why doesn't take that meta position? Hope you're clear with it. Okay, the next one more point, acetylating point can be preferred only para. It does not meant for ortho, neither meta. Okay, let us go for it. Here the next one more important question. Acylation of aniline, that is acetylated of aniline, prefers only the para product. Okay, let us go and identify why it is having such kind of nature. Okay, acylated of aniline is very less reactive in electrophilic substitution reaction. Okay, now you know very well aniline is actually what it is. This is benzene ring, aniline, this is NH2, this is lone pair of electron, the lone pair of electron which is involving for the resonance. So due to that negative charge will take over by ortho position and para position. So electrophiles also will be preferring ortho and para position due to the resonance of that lone pair of electrons involved in that resonance. So you know very well. Whereas here acetylating of aniline, what happened? So this is acetylated of aniline. Okay. Now this is NH C double bond O CH3. Okay, here also lone pair of electrons are there. This lone pair of electrons instead of involving for that benzene, it is donating to that acyl group. So what happened? This just resonance takes place in themselves only. So what happened here? There is a less donation to that nitrogen is having a less donation to that benzene ring, so automatically it donates to that amino, what it is, amide group. It's very less reactive than amino group. So naturally you will get NH here positive charge, double bond here negative charge, here CH3. So your resonating structure will be like this. So here what happens? Suppose what is the product you will get it? Suppose if it reacts with something else, bromine which is reacting with that acetylated of aniline. So what is the product you will get? You will get para product only. Okay, let us go and identify whether it is true or not. Okay, now this is benzene here, NH C double bond O CH3 combined with the bromine in the presence of pyridine. So what happened? You will get para bromo acetanilide. Okay, now here NH C double bond O CH3 and here Br and here HBr. Okay, now this para-bromoacetanilide, again it reacts with water. Water hydrolysis it takes place. You will get what it is. Para-bromoaniline, you will get it. Okay, so here what you will get it? Here NH C double bond O CH3 and here you will get Br with that hydrolysis H2O in the presence of acetic acid CH3COOH. So what happened? OH no? So automatically you will get aniline as the product along with that para bromo aniline NH2 and you will get it here what it is Br and here what it is CH3COOH. Here CH3 COOH. Here OH is there, no? CH3COOH. So that H will go and attach over here. Hydrogen. So automatically NH2 you will get it. And here CH3COOH. You will get acetic acid. So you will get para bromo aniline only is the major product. So from this we can identify acetanilide can give only the product of para compound. It cannot give ortho and para. Why? Because that resonance involves in that acyl group only. It does not involve in that benzene ring. Okay, when this lone pair of electrons involves in the benzene ring only, you will get ortho and para position of the electrophiles which will be attached over there. Hope you're clear with this, why it is going for that para position, why it does not go for that ortho and para position. This one it can prefers ortho and para position directing group. Hope you're clear all these points. Thanks for watching.